Okay, so our equations rewrite as the xr term and the m plus r plus 1 term after we shift all the terms to the highest power plus the sum start with m equals to 0 to infinity. And based on the power series, we want all the term with this part. So this part has to be equals to 0. Okay, so 4r minus 1, 2r plus 1, a naught x to the r equals to 0. And since my a naught is now 0, that is based on the definition of the extended power series. The a naught couldn't be 0. Then my 4r minus 1, 2r plus 1 has to be 0. So we get two roots of r. R1 equals to 1 over 4, R2 equals to minus 1 over 2. Okay? Then if we put this R1 and R2 into our original format, what look like? So for R1 equals to 1 over 4, then this term also needs to be 0. Okay, so this term will be the sum from m equals to 0 to infinity. 8 plus 8 times m plus 5 over 4, m plus 1 over 4 plus 10 times m plus 1 over 4, so 5 over 4, because plus 1 here, minus 1, okay, am plus 1 plus am, then the sum of x to the m plus 5 over 4 will be equals to 0. And let's just simplify these equations as much as possible. So that is equals to sum from m equals to 0 to infinity, 4m plus 7 times 2m plus 2, am plus 1 plus am, x to the m plus 5 over 4 equals to 0. Okay, so this is the simplified form. And we know that this part couldn't be 0. In order to let this whole term equals to 0, then the coefficient has to be satisfied to be 0. Okay, so when R1 equals to 1 over 4, we need to have am plus 1 equals to negative 1 over 4m plus 7 times 2m plus 2 times am, this relationship, so that this whole term can be equals to 0. Then we can try several numbers for the m. You can see how this coefficient look like. So let m equals to 0, 1, 2, until infinity, because m start with 0, right? So a1 equals to negative 1 over 14 a naught, a2 equals to minus 1 over 44 a1, that will be equals to 1 over 616 a naught, and etc. You can just guide this in a looping way. Then y1 x will be equals to the sum from x equals to 0 to infinity, am x to the m plus r, right? This r is when r1 equals to 1 over 4. Am is satisfied for this relationship, so that we can get from a naught x to the 1 over 4 times 1 minus 1 over 14x plus 1 over 616 x squared plus dot dot dot. Okay, so this is y1, which is your first independent, linear independent solutions. Then you can imagine when R2 equals to 1 minus half, that leads to your second linear independent solution. So for R2 equals to 1 over 2 half, then you can get this term, this term has to be 0, okay? So you have sum from m equals to 0 to infinity, 4m plus 1, 2m plus 2, am plus 1 plus am, x to the m plus 1/2 equals to 0. Since this term couldn't be 0, that means the relationship of this has to be 0. So you get the coefficient where am plus 1 will be negative 1 over 4m plus 1, 2m plus 2 am. Okay? And you can write several m numbers to get the relationship. You can also program that into the MATLAB. So y2 x will be equals to the sum of am x to the m plus r will be a naught x to the minus 1 over 2, 1 minus 1 over 2x plus 1 over 40x squared plus dot dot dot. Okay? So this is two linear independent solutions, and you will combine them with the coefficients. A naught. In order to solve what is the A naught, then you need to have basically the initial value problem or boundary value problem in order to solve completely for this unique solution of the ordinary differential equations. But for now, we can just linear combine with this y1 and y2 to get our final solutions. So our YH will be C1Y1 plus C2Y2. Then the C1 and the C2 are the A naught. You can just decide by the initial value problem or boundary value problem.